Okay, picture this. An absolute icon, a legend of aviation, the Concorde. Over 30 years, pretty much a spotless safety record. Then boom, in just 121 seconds, it's all gone. That beautiful supersonic jet crashes into a hotel just outside Charles de Gaulle in Paris. This was Air France Flight 4590, Paris to JFK. And for the passengers, mostly German tourists, this was supposed to be the trip of a lifetime. They were heading off on a cruise, 100 passengers, 6 cabin crew, 3 pilots. So our mission today is to really dig into the final report. We want to understand not just what happened, but the whole chain of events. It's quite surprising, of course, the impact it all had. The Concorde really was, well, it was stunning, wasn't it? A feat of engineering, just beautiful. First flew back in '69. And remarkably, no fatal accidents in all that time until this one.
Yeah, and that iconic shape, that delta wing, that was really the key. It was brilliant for flying at all sorts of speeds, subsonic, transonic, right up to supersonic. But like most things in engineering, there was a trade-off. For takeoff and landing, that wing needed really high speeds. And a high angle of attack, the nose pointed up quite steeply.
How high are we talking?
Well, think about a regular jet, like a Boeing 737. Takes off around, 140, maybe 150 knots? Concorde needed about 200 knots.
Wow. Okay. That's a big difference. And I guess that puts a massive amount of stress on everything, especially the tires.
Exactly. Huge stress. And the history shows it. Over its 30 years, Concorde had 57 tire bursts.
57? Seriously?
57. And 12 of those actually caused some kind of structural damage, bits of tire hitting the underside of the wing. And get this, 6 times, pieces actually went into the wing fuel tanks.
Into the fuel tanks. 6 times?
Yeah.
How was that not seen as a critical danger?
Well, there was one really serious incident back in '79 taking off from Washington. A tire burst, debris hit the wing, punctured a fuel tank's small leak, and it damaged the hydraulics. They couldn't even get the gear up.
Okay, so they knew this could happen.
They did. There was a big investigation. They recommended stronger tires, better protection for the hydraulics, but, and this is key, they looked at the fire risk from a fuel leak like that and decided it was very small.
Very small. After a fuel tank was punctured? That's hard to believe now.
It really is. It kind of shows the thinking at the time, maybe. They knew the vulnerability, but didn't quite grasp the worst-case potential.
So they underestimated it. What else was unique about Concorde systems? The fuel must have been complex, too.
Oh, yeah. Very complex. 13 tanks in total, most in the wings and body, but also a trim tank right at the back. They could pump fuel back there to shift the center of gravity, which was crucial for managing that delta wing, especially on takeoff. And power came from 4 Olympus turbojets, big engines, just outside the main gear. They had special variable intakes for supersonic flight and also secondary air intakes underneath. Those become important later. And all 4 had full reheat afterburners for about 18% extra thrust on takeoff.
Okay, so a complex machine, known tire issues, that previous incident, you'd think they'd be extra careful. But the day of the crash, July 25th, 2000, it sounds like things were already a bit messy from the start.
They really were. For a start, the actual plane they used wasn't the one originally scheduled. It was a last-minute swap. And then right away, there was a problem with a thrust reverser on one engine. It was technically a dispatchable fault, meaning they could still fly, but with a performance penalty. Engineering said they'd fixed it, though.
Okay, a swap, a technical glitch, anything else. Didn't I read something about the passengers or bags?
You did. Turned out there were quite a few passengers, mostly the German group, who weren't on the original manifest. This meant 19 extra bags got loaded, added a bit more weight.
A bit more weight.
Yeah.
On an aircraft already sensitive to weight, I imagine.
Exactly. So you've got the plane change, the reverser issue, the extra weight.
How about the crew? Were they familiar with these kinds of issues?
The crew was top-notch. Extremely experienced. The captain, 54 years old, nearly 13,500 hours total flight time, over 300 on Concorde. The first officer, 50, over 10,000 hours, and almost 2,700 hours on Concorde. He was even a simulator instructor for it.
Oh, yeah.
And the flight engineer, 58, over 12,500 hours total, nearly 940 on Concorde. This wasn't unusual for Air France's Concorde pilots. It was a really small, very experienced group. Only about 30 pilots flew it in total.
Incredible experience. So what about their pre-flight planning that day, with all these little issues piling up?
Well, they worked out their fuel needs, decided on 95 tons. That put the aircraft very, very close to its maximum structural takeoff weight. They calculated their key speeds, V1, the go-no-go speed at 150 knots. V rotation, when they lift the nose, at 198 knots.
Yeah.
And V2, the safe climb speed if an engine fails, at 220 knots.
Okay, but was the weight calculation accurate?
Well, the dispatcher figured they'd burn about 2 tons of fuel just taxiing to the runway, but they actually only used about 800 kilograms.
Less fuel burned means heavier at takeoff.
Yeah, exactly. It meant they were roughly 800 kilograms over the maximum allowed takeoff weight when they started rolling.
Overweight, on top of everything else.
Precisely. And while they were taxiing, the crew actually talked about another recurring electrical fault with the rudder control system. It kept switching out of its primary mode.
Another fault?
Yeah. They decided to just ignore it for takeoff, considered it another minor dispatchable issue. Then, just minutes before departure, they did the fuel transfer, moving fuel back to that trim tank to get the center of gravity perfect for takeoff, right at 54%. That part went fine.
Okay, so they're lined up, overweight, couple of known glitches, but ready to go.
Yeah.
What else is happening right then? This is where the other plane comes in, right?
This is the absolutely critical piece. Right about then, a Continental Airlines DC-10 is taking off from the exact same runway, 26, right? And as it takes off, a metal strip about 43 centimeters long falls off one of its engines.
Just falls off. Did the DC-10 crew know?
No indication in their cockpit at all. Nothing. And crucially, nobody inspected the runway afterwards. Back then, France only required 2 runway inspections per day, so this piece of metal just sat there, unseen.
Oh, wow. So the Concorde is lining up, ready to go, and there's this piece of metal waiting for it. That sets the stage for those 121 seconds.
It does. The captain gave the standard takeoff briefing, the plan. Below 100 knots, stop for pretty much any warning or tire flash. That's a sudden pressure loss. Between 100 knots and V1, there'd be stricter stop for an engine fire, tire flash, or a specific failure call-out. But after V1, that's it. You go. The plan was, if something happened after V1, they'd take off, circle around, and land back on 26/10.
Right. Standard procedure.
What about the final checks right before they push the throttles?
Just before takeoff, the flight engineer confirmed the brake temperatures were okay, around 150 degrees. The captain specifically asked if they were even left and right. The engineer said, about the same. That detail becomes important later. We've also got the wind check. 0.09 degrees at 8 knots. That's a tailwind. A tailwind. Doesn't that affect takeoff performance?
It does. With a tailwind, the maximum allowable takeoff weight should actually be reduced because of tire speed limits, but somehow this was missed in their final calculations.
Another thing. Okay, so 14.42 and 30 seconds UTC. They start the roll.
That's right. Captain pushes the thrust levers forward, engages the reheats. You can imagine the noise. Concorde starts accelerating. 24 seconds later, first officer calls 100 knots. Flight engineer confirms 4 greens. All engines and reheats look good. 6 seconds after that, first officer calls V1. That's the point of no return.
They're committed. This is where it happens.
14.43.09, just seconds after V1. The flight data recorder shows a slight yaw to the left. They're about 1,700 meters down the runway, and they roll right over that metal strip left by the DC-10. Less than half a second later, there's a noise on the cockpit voice recorder. Almost certainly the sound of a tire exploding on the left main landing gear. They later found the metal strip and bits of tire right there on the runway.
The tire burst, that known vulnerability.
Exactly. And just 1 second after that, they're at 178 knots, 8,810 meters down the runway. Another noise change in the cockpit. What's happening is pieces of that exploded tire are hitting the underside of the left wing, right around fuel tank number 5. The impact is so violent, it actually buckles the wing skin inwards. Inwards. But the tank is completely full of fuel, so that impact creates a massive pressure wave inside the tank. With nowhere else to go, that pressure wave blows a hole outwards, the tank ruptures,
and the fuel.
Dozens of liters start gushing out immediately, and it ignites, almost instantly. The most likely cause was broken electrical wires in the landing gear strut, damaged by the tire explosion, creating sparks. And crucially, because the landing gear was still down, it created this sort of turbulent air zone right behind it. That turbulence actually helped the flames stabilize and keep burning instead of just being blown out by the speed.
So the gear being down actually fed the fire. That's unbelievable.
Made a horrific situation even worse. Immediately, the plane starts pulling hard to the left. Not because of engine failure yet, but because of the damaged tires dragging and the sheer aerodynamic drag from this huge fire under the wing. Captain's putting in right rudder to fight it. Then, just 2 seconds later, engines 1 and 2, the two on the left side, start losing power.
Why? The fire.
Yeah. Engine 1 probably ingested bits of tire debris and hot gas. Engine 2, closer to the gear, and the main fire definitely swallowed hot gases. Both engines start surging, compressor stalls. You hear the first officer and flight engineer shout, "Watch out," as the go lights for those engines go out. They're at 187 knots now, still 8 knots below their planned rotation speed, VR. And with engines 1 and 2 failing, the plane yaws violently left.
They haven't even lifted off properly, and they're losing engines and fighting a massive fire.
The captain starts pulling back to rotate, but it's slower than usual. Maybe he knew the speed was too low, or maybe he was just trying desperately not to veer off the side of the runway. As the nose comes up, the airflow changes, and that probably causes engines 1 and 2 to suck in even more hot gas, maybe through those secondary air intakes underneath we mentioned earlier. Both engines surge again, thrust drops almost to idle. Then the first engine fire alarm goes off. The flight engineer asks, "Shut down engine number 2, captain confirms. Engine fire procedure."
What's air traffic control doing? They must see this inferno.
Oh, they see it. The controller calls them Air France 4590. You have flames trailing behind. And you can even hear another pilot on the frequency just observing, saying something like, "It's really burning, eh? Burning hard, and I'm not sure it's coming from the engine." That observation turns out to be quite important later.
Wow. So they're airborne now, but just barely.
Yeah, they finally lift off, but they actually run over the edge lights on the left side of the runway as they do. They're flying, but they're in massive trouble. Their airspeed is only 200 knots. Remember, their target engine out climb speed, V2, was 220 knots. They're too slow. They simply can't climb, can't even hold altitude properly. The first officer keeps calling out, "Speed, speed!" Engine 1 is badly damaged, even if it's producing a tiny bit of thrust. Engine 2 is being shut down following the procedure. Engines 3 and 4 on the right side have automatically gone into contingency mode, basically, full power, trying to compensate.
Airborne, slow, 2 engines out on one side, huge fire. What options did they even have?
Not many. They're only at about 100 feet. ATC radios, "Priority return to the field is yours." The flight engineer tells the first officer, "Gear, get the landing gear up." The first officer hesitates. The procedure, if you suspect gear damage, is actually to leave it down. But the captain overrides, orders gear up. The first officer tries. Nothing happens. The gear won't retract. The investigation later figured the main gear door on the left side was probably damaged by the tire explosion, jamming the whole retraction sequence.
So the very thing that caused the rupture and fire now prevents them from even trying to reduce the fire by getting the gear up. It's just one thing after another.
It's relentless. About 20 seconds later, 14.43.55, the flight data shows the plane starting to roll uncommanded to the left. The fire has been burning under that wing for long enough now that it's starting to melt the elevon, that's a control surface on the trailing edge that acts as both elevator and aileron on a delta wing.
Losing flight controls.
Losing control. The nose pitches up even more, the angle of attack increases, making things worse. The captain's fighting it. The first officer hears ATC mention landing at Le Bourget Airport nearby and calls out, "Le Bourget, Le Bourget." Maybe a last desperate thought.
Just trying anything.
The engine fire warning comes back on. Engine 1 surges violently again, losing whatever little thrust it had left. Now there's virtually no power on the left side. The plane rolls harder left, reaching over 100 degrees of bank, almost upside down. The ground proximity warning system starts screaming, "Pull up, pull up." In a final desperate move, they reduce thrust on engines 3 and 4 on the right side, trying to use asymmetric thrust to level the wings. It's no use. Seconds later, 14.44.31. It hits the hotel in Gonesse. Everyone on board, 109 people, and 4 people in the hotel. Gone.
Just devastating. Listening to that sequence, it's clear how one thing led to another, how known issues, external factors, they all just converged. It feels almost inevitable once that tire hit the metal strip. So the investigation, what did they pinpoint as the absolute cause and what needed to change?
Well, the investigation started right away, obviously. And pretty quickly, examining the wreckage, they found the left landing gear bogie, the whole wheel assembly. And they noticed a critical spacer was missing.
The spacer?
Yeah, a part designed to keep the wheels aligned properly on that bogie. The investigators then actually found the missing spacer. It was sitting in an Air France maintenance workshop. They'd done work on that specific landing gear just a few days before the crash.
So Air France maintenance left out a part. That sounds huge.
It was definitely a very serious lapse, as the report called it. A big mistake by Air France. However, the investigators dug deeper. They looked at all the performance data from the taxi and takeoff roll, checked those brake temperatures the crew discussed.
Which were even on both sides.
Exactly, which indicated the wheel alignment was actually okay until the impact with the metal strip. So their conclusion was that while leaving the spacer out was a serious maintenance error, it didn't actually cause or contribute to the accident sequence itself.
Okay, so not the spacer. It comes back to that metal strip from the DC-10.
It does. The focus shifted heavily to that strip and the Continental DC-10. They found out that specific metal wear strip had been replaced twice recently. And crucially, it hadn't been made or installed according to the engine manufacturer's instructions. It had way too many drill holes, 37 instead of 12. And an adjacent piece was slightly too long, which likely caused extra stress and wear on the strip that eventually broke off.
So faulty manufacturing, faulty installation on another airline's plane. Combined with the lack of runway inspection, it's a chain reaction. What about the Concorde crew? Was there anything that they could have done differently in those 2 minutes?
That was a major part of the investigation. And the finding was pretty stark. Concorde pilots had simply never been trained for anything like this. Losing 2 engines on one side simultaneously with a massive uncontrollable fire below V2 speed. It was an unprecedented scenario. Once they were past V1, when the tire burst, rejecting the takeoff wasn't really an option. At that speed, it would have been a guaranteed high-speed crash off the end of the runway, total loss. And once airborne, they were too slow, couldn't climb, couldn't retract the gear which was feeding the fire. The fire was inevitably going to destroy the wing structure and flight controls. The investigators concluded there was very little to nothing the crew could have done differently once that tire burst.
So basically, once that strip was hit, their fate was sealed. That's chilling. It really puts the focus back on preventing that initial event, doesn't it?
Absolutely. It highlights how critical every single element is, from maintenance standards on all aircraft to simple things like runway checks. The ultimate official cause was pinned on that single burst tire, an event that, as we know, had happened many times before without disaster, leading to this catastrophic and irreversible tragedy. As a direct result, Concorde's certificate of airworthiness was pulled immediately. Grounded.
And they had to make changes before it could fly again.
Big changes. They spent over a year implementing them. Kevlar lining was added inside the fuel tanks to resist punctures. Electrical wiring in the landing gear areas was rerouted and shielded. And they developed completely new, much more boost-resistant tires, the Michelin NZG tires, plus some other smaller upgrades.
So they directly addressed the failure seen in the crash. Did it work? Did Concorde make a comeback?
Well, it was supposed to. The modified Concordes were all set to return to service, but then, just weeks before the planned relaunch, September 11th, 2001 happened.
Oh, right. The 9/11 attacks.
Yeah. That changed everything in aviation. The market collapsed, particularly for premium travel. Confidence was shaken. It basically sealed Concorde's fate. The airlines couldn't justify the operating costs anymore in that new environment. British Airways flew the last commercial Concorde flight on October 24th, 2003, and that was the end, at least for now, for supersonic passenger travel. And just as a side note, the whole investigation wasn't without controversy. The British accident investigators later raised serious concerns about the French-led investigation, saying they were denied full access to some evidence and debris. So even these things can get complicated.
What a story. This deep dive really underscores how even the most advanced technology, flown by the most experienced people, can be vulnerable. A series of small things, a known weakness that was maybe underestimated, an external random event, all lining up to create an absolute catastrophe.
It's a powerful reminder, isn't it, that safety isn't a destination you reach. It's a constant process. You have to keep learning, keep questioning, especially from the worst outcomes. You can't afford to think that won't happen.
Absolutely. So it makes you think, doesn't it, about those hidden connections, those vulnerabilities we might not see in complex systems all around us, and how vital it is to learn from every single detail, no matter how small it seems at the time. Definitely something to keep mulling over. We'll be back with another deep dive soon.